Hey guys, we talked about dividing rational expressions. We've multiplied rational expressions, and now we're going to talk about adding and subtracting rational expressions. So, our goal and our objective for this lesson is that you can add and subtract rational expressions by finding and applying the least common denominator. So let's think about what we need to know when we add or subtract two fractions. And I'm going to go ahead and take a snip of this so I can fill in the guided notes with you. But if I want, I go ahead, if I had my time machine and I could take you back in the day to when you were in, I want to say about fourth grade, and you were learning how to add fractions. One of the things that you had to know in order to add or subtract fractions was that you needed to have a common denominator. Remember that? Is that coming back to you guys? Yeah, you needed a common denominator. And the same is true when you add rational expressions. Just like when we were multiplying and dividing, it had the same rules. The same is going to be true when we add or subtract. All right. We need to make sure that we make both denominators of the expression common, basically the same. Okay. So how we're going to do these steps is first we're going to factor the denominators, and then we're going to write the least common denominator on the side. All right. We're going to compare the least common denominator to each term. And whatever is missing, we're going to go ahead and multiply both the numerator and denominator by that side. And then finally, we're going to simplify the problem by combining like terms. And I'm going to do it with a fraction just to kind of bring you guys back to what I'm saying. Like, if you were adding 1/2 plus 1/4, you would look at both the denominators. You would look at 2 and 4, and you would say, what is the least common denominator? And if we look at both those two, we know the least common one is going to be 4. We're looking of a multiple. The least common, pretty much multiple between 2 and 4. And it's 4, right? It's going to be 4. So I would know that I want my denominator to be 4. So I'd write that on the side. Okay. And then I would look and see what I need. I look at both of those denominators and see how can I make a 4 happen in both those denominators. Well, my first fraction, that would be by multiplying by 2. Okay, and remember, with fractions, whatever we do to the denominator, we got to do to the numerator and vice versa. Because I know if I multiply by 2, that's going to give me a 4, right, or my LCD. Same over here. If I look at this other fraction, I'm good to go. I don't have to change it because it's already a 4. So I would change just the first fraction by multiplying the top or bottom by 2. So that would change the first fraction to a 2 over 4, right? 1 times 2 is 2. The bottom 2 times 2 is 4, plus this fraction would stay the same because it already has that least common denominator in it, 1 over 4. And then what we do to add fractions, remember when we add fractions, we would add in the numerator only. Okay, so our denominator stays exactly the same. And then with our numerator, we would just add 2 plus 1, and we would have 3/4. All right. If this was a subtraction problem, same thing would happen, same process, except we would be subtracting in the numerator only. All right. So let's go through those same steps, just like we did with fractions back in fourth grade. We're going to go through the same steps with rational expressions. And I am going to first move this up a bit. Let's see if I can move this up. And we can start looking at our examples. Here we go. Let's snip example number 1. Again, we're going to go through each one of those steps. And here we go. And I'm going to move this to the side. Actually, I want to show you guys the steps because I want us to always remember the steps that we're doing when we do this. So the first step is factor the denominators, and we're going to write the least common denominator on the side. So the first thing I want to do is look at both these the denominators, and I see that they can be factored. I'm subtracting here. So I'm going to factor this first denominator. And if I look at this, this factors into a x plus 2 and an x plus 1. Then I'll look at the second denominator, and let me change the color here to red. If I look at the second one, it factors into a x plus 2 and an x plus 1 as well. So if I look at both of these, they're both, the denominators are already in common, right? They both have the same denominator. So it's not much that I have to do. The least common denominator is going to be an x plus 2 and an x plus 1. So now all I need to do is subtract in the top. I am going to have a 7, and I'm just going to put it all together. It's kind of like the smush in multiplication. I got a 7x plus 4 minus, and then I'll make sure, you got to be careful, make sure you put your next fraction in parentheses because you're subtracting a 3x minus 4. All right, and that is important. That's so important. Because when we go to simplify and combine like terms, right? In our numerator, we're going to have that 7x plus 4. But then we got to carry this negative. And remember I said that's a negative 1, right? So we're multiplying this negative 1 all the way through. So that's going to be a negative 3x plus 4. All right? And that's over my x plus 2, x plus 1. And our last step was, if we look at our last step, we need to simplify the problems by combining like terms. So let's go ahead and combine like terms. If I look at it, my two like terms are the 7x and the negative 3x. If I take 7x minus 3x, that's going to give me a 4x. All right, so I would end up with a 4x. And then I got a plus 4 and a plus 4. That would give me a plus 8. 4x plus 8. And that's over x plus 2, x plus 1. All right, so there is our, let's erase that. Okay, so there's our first example, 4x plus 8 over x plus 2, x plus 1. All right, let's go to the next example. If I'm looking at the next example, and I don't like how this is highlighted. There we go. If I look at the next example, I can already see something is different here. My denominators are not in common. So I need to go with step number 1 and look at what my least common denominator is. Well, I can't factor these, but I know what they have in common is they both have an h and they have an x. So in order to find my least common denominator, it's going to be what they have together. The least thing that they have together, well, it's the 8 and the x. Okay, so that's my LCD. It's the 8 and the x. So then I have to look. I got my least common denominator right here. I got to look at the first fraction, right? And I see, what is this fraction missing? Well, this first fraction, if I look in the denominator, it is missing the x from the LCD. So that means that I need to multiply both numerator and denominator of this fraction by x. Denominator has to be multiplied by x and numerator has to be multiplied by x, right? I already know when I do that in the denominator, it's going to give me my LCD, right? So I'm going to have a 8x. Bam, I got it here. What I would have in the numerator, and I'm just going to write it as one big super fraction. In the numerator, what I would have is a 5 times x, or a 5x. Now we got subtraction, so I'll bring the subtraction down in my numerator. And then I need to look at my second fraction. Notice the second fraction already has our LCD, so we don't need to multiply anything, which is step 2. Remember? That's where we're at, step 2, multiplying the numerator and denominator by whatever's missing. Well, we don't need to do that because nothing is missing for this fraction. So I can just carry the numerator down into my super fraction down here. That numerator would be 3. So last step would be to combine like terms. No, in the numerator only. Notice in the numerator there are no like terms to combine. Okay? So this is our final answer. 5x minus 3 over 8x. Okay, so we are finding the least common denominator. So you're basically looking and making sure you include all those factors. Then the next step, whatever one fraction does not have, we'll multiply both numerator and denominator by that part that it does not have, right? And then we're going to take whatever we multiply for each fraction, put it down into our super fraction like we did. So in this one, we multiplied the numerator by x. So we know we ended up with 5x. We carried that down. And for the next fraction, we didn't have to do anything. So we just moved that minus 3 down into the numerator. All right, let's try the next example. Nope. Next example. If we look at this next example, same thing. We gotta figure out what our least common denominator is. Now let's look at this though, okay? What I'm gonna do with this 9, I got a 9 and I got a 3x. What I'm gonna do with this 9 is I'm gonna break this down so you can see it. Okay, I'm going to change this 9. We know 9, if we factored that, which we can, it factors to a 3 times 3, right? So 9's factors is 3 times 3. And then over here, we got a 3x, right? So if we look at it, and we got to think of the least common denominator, all right? This fraction over here has a 3, right? But it's missing a 3. Okay, so because we gotta have 2 3s. Our other fraction has 2 3s. So we want all of that. We want the 2 3s, right? So that would cover the 3 here, right? Because they each have a 3. And then we gotta add the other 3. Right? Because one of the fractions has 2 3s. Then it has a x. So we need to also include a x in our least common denominator. Now, if I look at that, my LCD then would be a 3 times 3 times x, or a 9x. And I am just going to now think about what is each fraction missing from our LCD. Let me change the color as we talk about that. So I'm going to change to a blue. So let's look at the first fraction. The first fraction has the 3 and the 3 in the denominator, but it's missing the x, right? So I have to multiply this denominator by an x, and I gotta multiply the numerator by an x. So I know for the numerator of my superfraction, for the first part, it's going to be a 4 times a x. And I can just bring that down. It's going to be a 4x. All right. Let's look at my second fraction. My second fraction is missing a 3, right? It has the 3, but it doesn't have the second 3. It has the x, but it's just missing a 3. So I got to multiply the denominator times 3, and I'm going to multiply the numerator times that 3 as well. And if I think about it, when I do that, the second part, or the second fraction, the numerator turns into a 1 times 3, or 3. So I'm going to add that plus 3 down in my superfraction. So I would have a 4x plus 3. Combining like terms. Again, if we look in the numerator, there are no like terms to combine. So this is my final answer, 4x plus 3 over 9x. Again, finding the least common denominator, multiplying what's missing by from the two fractions, both numerator and denominator, by that amount, and then combining them and combining like terms. Let's go to the next example. Yeah, we're kicking it up a notch with example 4. Here we go. So example 4, just kicking it up a notch. Example 4 says 5x over x squared plus 7x plus 10 plus 4 over x plus 5. We're going to go through the steps. Let's factor the denominators first. That's step number 1. So if I look in the denominator of this first fraction, it would factor as a x plus 5 times x plus 2. Now the second fraction, we can't factor that, right? That it is what it is, right? It's just an x plus 5. So let's start thinking about what our LCD is. And I just always play the what's missing game when I figure out the LCD. What is missing? Okay, so let's think about this. So both of them have the x plus 5. Okay, so that has to go as our LCD. X plus 5. All right. What else? What is missing? Well, if I look back up here, we need to also include x plus 2 in our LCD. X plus 2. I want factors of everything. All right. So x plus 5, I don't need to write it twice because it's there only once in both of those fractions. And then x plus 2, I only need to write it the one time, even though it's not included here. And here we go. Let's then go to each one of the fractions. We need to make sure they have everything. So if I look at the first fraction, it has our LCD, right? It has x plus 5 and x plus 2. So am I multiplying numerator denominator by anything? If you said to yourself no, you are absolutely right. Yeah, because it already has the least common denominator. So I'm just going to take the 5x and I bring it on down to my numerator. So 5x, excuse me. Sorry guys, 5x comes down. Let's look at the second fraction. What's missing? Well, it has the x plus 5, but it does not have the x plus 2, right? So that means that I'm going to multiply both numerator and denominator by the missing x plus 2, okay? And when I do that, I would end up in the denominator is our least common denominator, right? So we're not worried about that. The numerator, I would end up with a 4x plus 8, right? Just distributing, using distributive property. 4x plus 8. So I would have a plus 4x plus 8. All right. Now my last step, I'm going to go ahead and combine like terms. So the two like terms that we see is the 4x and the 5x. And together, that is 9x. So we got 9x plus 8. And it's over my x plus 5 and x plus 2. All right, guys. Let's move on to the next problem. Our next example, again, we're kicking it up a notch. 16 over x squared minus 16, and it's added to 2 over x plus 4. All right, guys. First step, we're going to look at the denominators and factor the denominators. Ooh, this is that difference of squares factoring. So I'm factoring this denominator as a x plus 4 times x minus 4. And then the other denominator, if we look at that, that's already factored as x plus 4. All right, let's go ahead and write our LCD. Let's see, we got to grab all the factors of the denominators to write our LCD. So we know we need to have a x plus 4. That's included in the denominator of both fractions. So we're going to have an x plus 4. We also need to have our x minus 4. So we're going to have an x minus 4. That's it, right? There's our LCD. Now let's look in the numerator, see what we need to add for both fractions. The first fraction, nothing, right? Because the least common denominator is the denominator of the first fraction. So I can just take my 16 as is and bring it on down here, okay? So writing my 16 plus, let's look at the second fraction. I have to multiply this second fraction by what it's missing. What's missing? Well, it's missing the x minus 4. So I'm going to multiply both numerator and denominator by the x minus 4. So when I do that, what am I left with in the numerator? Well, I would have a 2x minus 8. 2x minus 8. And if I need to combine the like terms, what I would end up with is a 2x plus 8 over x plus 4, x minus 4. All right. Okay, let's go on to our next example, example 6. Example 6. All right, example 6, we're kicking it up a notch higher. Example 6 has 5 over 6 times x minus 6x minus 18 minus x minus 1 times 4x squared minus 14x plus 16. First step, guys, we got to factor out the denominator. So I'm looking at this denominator, I'm thinking GCF, right? I can factor out the 6 and the 18. They both have a common factor of 6. So I'm going to pull out a 6 in the denominator, and I would be left with a x minus 3. All right. Now I'm going to factor the denominator of this second fraction. This one is it, and you know, I gotta be careful here, okay? Because I could go ahead and go for the bottoms up method, But before I go for bottoms up, I'm going to go ahead and take out a GCF. Because if I look at this, guys, I notice it has a common factor of 2. So I'm going to pull that 2 out. All right. And I would be left with, in the denominator, when I pulled that 2 out, I would have a 2x squared minus 7x plus 3. All right, now I'm going to go to the corner here because I am going to do the bottoms up method because I know I can factor this again. So I'm going to use my custom pen, which I hope is not white. It is. Okay, let's change the color. I'm going to use my custom pen of fuchsia. And I am going to quick factor this. So, you know when Miss Bennett does her bottoms up method that she absolutely loves, I take my leading coefficient and I multiply it to the back, right? And I rewrite it by product sum, which is what we know better. So I have a x squared minus 7x plus 6, right? And then I just think to myself, the same old, right? What multiplies to a 6 and adds to a negative 7? I know that would be a x minus 6 and x minus 1, right? And I need to now divide by my leading coefficient, which is 2. So I'll divide both of those by 2 and then simplify what I can. This first factor, if I look at it, I can simplify that to an x minus 3. What I can't simplify, I take the bottom and move it up. So this would be a 2x minus 1, right? So let's go back up here. We know this factors as a x minus 3 times 2x minus 1. Okay. Next, let's talk about what our least common denominator is. All right, what's our least common denominator? And just so we can see with this these integers, okay, we can factor this 6 more. We know 6 factors to a 3 times a 2. All right, because I want you to not get confused with the integers. All right. So now we can kind of see what we need. Well, we know we need a 3, right? Times a 2, right? Times our x minus 3, all right? Now we already have x minus 3. We look at this next fraction. We already have x minus 3. We already have 2. We also need a 2x minus 1. Okay. Now, let's go to each one of the fractions and let's start thinking about what we don't have in each one of the fraction or what's missing. So for the first fraction, we got the 3, we got the 2, we got the x minus 3, right, from our least common denominator. What we're missing is the 2x minus 1. So I'm going to multiply both numerator. Ooh, I want another color. There we go. I'm going to multiply both numerator and denominator by 2x minus 1. Okay, so I'm multiplying the denominator by that and the numerator by 2x minus 1. All right. When I do that, the denominator just turns into our LCD. So I'm not worried about the denominator. The numerator is what I'm worried about. All right, if I multiply that, the 5 by 2x minus 1, I would end up with a 10x minus 5, distributive property. All right, so I would have a 10x minus 5. Over here, I need to get my charger. Over here, guys, I'm looking at the denominator of this second fraction and what is missing. Well, we're missing the 3. Okay, we already know we're missing 3. So that means I got to multiply both top and bottom by a 3. What else are we missing? Well, we got the 2. we got the x minus 3, and we got the 2x minus 1. So the only thing we got to multiply both top and bottom by is a 3. So I'm going to bring the minus sign in, right, to keep this kosher. And then I'm going to multiply x minus 1 by a 3. So I would have a 3x minus 3. And I'm going to put parentheses here so I don't mess this up with my signs, okay? Because we know that minus is a negative 1. So I will have a 3x minus 3 in the numerator. And now I'm going to make this nice and clean, okay? Remember, this is a negative 1. So we're going to multiply that negative 1 in. So we know this would turn into a minus 3x plus 3, all right? So in my numerator, I have a 10x minus 5 minus 3x plus 3, and it's over 3. Now I'm going to combine these. 3 times 2 is 6. I'll write it again now as 6 because we can see it. We don't need to see it anymore now. And my 2x minus 1. All right, now the last. Let's go ahead and combine our like terms. Here we go. If I combine my like terms, 10x minus a 3x is going to be 7x, and a negative 5 plus 3 is going to be negative 2. And this is over 6 times x minus 3 times 2x minus 1. All right. Woo! A lot of factoring, but we did it. Okay, we did our steps, found our LCD, multiplied both numerator and denominator by what they didn't have, and then we subtracted and combined like terms. All right, let's go to the next problem. Nope, let's go to example 7. All right, for example 7, it says we have a 4 over x squared minus 5x plus 6 minus 5 over x squared plus 12 plus x minus 12. Let's go ahead and do the first step of factoring the denominators. If I look at the denominators here, I know that this has to factor as an x minus 6x plus 1. And the second denominator has to factor, I'm looking for two numbers multiplied to a negative 12. Ooh, I know. But add to a positive 1. That's a x plus 4, x minus 3, right? Awesome. Okay, so now I have to find my LCD. Remember, I'm writing my LCD to this side, and I'm going to write it down here. So my LCD, let's write in our custom pen, is going to be all of our factors. So I'm going to take my x plus 6, or x minus 6, sorry, and then my x plus 1. And then my x plus 4. And then my x minus 3. Combine those all together, right? Then I go back up here and I'm going to look at the first fraction, okay? Now we see what's missing, okay? So from the first fraction, what are we missing? Well, we're missing the x plus 4 and the x minus 3. So here we go. Okay, so I multiply both top and bottom, numerator and denominator, by what's missing. X plus 4 times x minus 3 in the denominator, x plus 4 times x minus 3 in the numerator. And guys, I am going to make this very simple, okay? I already know x plus 4 times x minus 3 is x squared plus x minus 12, right? That's where I got it from. So I'm just going to rewrite that up here because it's going to make it so much easier to go ahead and simplify, right? So I'm going to just write this. I know x plus 4 times x minus 3 is x squared plus x minus 12, right? So now when I multiply it, this is easier when I'm multiplying, right? I would have a 4x squared times a 4x. Get out that. And minus a 48. All right. Look at that. Okay, let's go to the next one. All right, so the next thing I will be multiplying. Let's see what's missing. Well, this had the x plus 4 and the x minus 3, but it is missing the x minus 6 and x plus 1. So I need to multiply both numerator and denominator by the x minus 6, x plus 1. That's the numerator or denominator. The numerator x minus 6 and the x plus 1. All right. Again, to make this easier when I multiply the numerator, because I'm not worried about the denominator. I know the denominator is my LCD. So to make it easier when I multiply the numerator, I'm just going to change this back into what it was. Well, the x minus 6 and x plus 1 was just this, right? We know it was the x squared minus 5x plus 6. So let me rewrite it as that, right? I'll say, I know this is going to be x squared minus 5x plus 6. Makes it so much easier to multiply that 5. Now, I would have, and be careful, I'm bringing my minus sign down, but I'm including my parentheses, okay? I would have a minus 5x squared minus 25x plus 30. All right, and we know this is a negative 1. All right, so when we're going to multiply that negative 1 into each term, it changes the signs of everything, guys. Don't let that negative 1 mess you up, okay? So down here, I'll write down here. Let's simplify this and combine like terms a little bit, okay? So we know in the numerator, we have a 4x squared plus 4x minus 48 minus 5x squared plus 25x minus 30. And it's over x minus 6, x plus 1, x plus 4, and x minus 3. All right. And now I'm going to go ahead and combine like terms in the numerator. Here we go. Combining like terms in the numerator. I would have I got a minus 5x squared and a plus 4x squared. If I combined those like terms, I would have a minus x squared. The x's, I got a plus 4x and a plus 25x. Well, that's a plus 29x. And then right here, I got a minus 48 and a minus 30. And that is going to be a negative 78. And then all of this is over my factors. X minus 6, x plus 1, x plus 4 and x minus 3. All right. So same steps, more factoring, but same stuff, right? Finding our LCD, looking and seeing what's missing from both fractions, top to bottom, multiplying by that, and combining like terms. All right, let's go to the next one. Almost there. This is our last one. Our last one. Well, second to last. We got our application problem. All right, example 8. Ooh, we get a 3x minus 1 and an x plus 1. I'm looking and I don't have to factor. Yes. These are two examples where we don't have to factor. So we can go straight to our LCD. What are our factors? Well, it's 3x minus 1, not plus, minus 1, and x plus 1. Right? Those are my two factors. Then I do the same thing. I look at both of those problems and I say, hey, first fraction, what's missing? Well, I got the 3x plus 1. I'm missing the x plus 1. So I'm multiplying both numerator and denominator times my x plus 1. All right. So I don't care about the denominator because I got my LCD here. I'm worried about the numerator. All right. Easiest thing to do, guys, is just write your fraction out now. So I would have an x plus 1 times an x plus 8. Then plus, well, what is this fraction missing? Well, it has the x plus 1, but it's missing the 3x minus 1. So that means I got to multiply both numerator and denominator by 3x minus 1. Okay, so that means that I don't care about the denominator, right? That's just my LCD. I care about my numerator. And in this case, guys, the easiest thing to do is just write out your factors. X plus 3 times 3x minus 1. Don't try to multiply it here. Don't try to do it there. Just wait. Okay, now the next step, I'll simplify. Okay, so let me see if I can simplify the numerator by multiplying the first part. I'm going to FOIL the first part out. Okay, my x by x is x squared. My x times 8 is 8x. And then a 1 times x is 1x. So a 8x plus a 1x is a 9x. And then my last step, a 1 times 8 is 8. All right. Let's go to the next one. This is all plus ax times 3x is going to be a 3x squared. And then ax times negative 1 is a negative x. And then a 3 times 3x is a 9x. So a 9x and a minus a negative x, right, is going to be an 8x. So we know this is plus 8x. And then my last one, a 3 times a negative 1 is negative 3. Now, let's go ahead and put this all over our denominators. 3x minus 1 and x plus 1. And then let's combine like terms. Well, I end up with a, in the numerator, I got an x squared and a 3x. Well, that would just be a 4x squared, right? So got those. Let's look at, I got a 9x here and an 8x here. Well, that's a plus 17x. So we got those. And then I got a 8 and a 3. Well, that is a plus 5. So a 4x plus 17x plus 5 all over 3x minus 1 times x plus 1. Perfect, perfect, perfect. And No, we don't need to save this. Nope. Let's do our last thing, our application. Here we go. Application. Put in some application. Here we go. We got a question that says the perimeter of a rectangle where side A equals 5 over 2 times x minus 3 and side B equals 4 over 3 times x plus 1. We're going to find the perimeter. Okay, perimeter. Let's think about it. Perimeter meant that I would add all the sides. So I have side A is 5 over 2 times x minus 3, right? And then I have a side B is a 4 over 3 times x minus 1. Now here's the thing. If I'm talking about the perimeter of this, I'm talking about both of these times 2, okay? So that means that I have to multiply both of these perimeters times 2, which I'm going to do. And remember, we multiply fractions. We multiply straight across. So I'm just going to change this to a 10 because it's two sides, right? Two sides are 5x over 2x times x minus 3. So I'm going to change this one to a 10 over 2 times x minus 3. And this one would be a 8 over 3 times x minus 1. Now remember, perimeter, we add the sides. We've already doubled both of the same lengths from here to here and here and here. So that means we're going to just add those doubled lengths together to find what the perimeter is. And so that would be a 8 over 3 times x plus 1. We are finding the perimeter of this rectangle, and we have doubled the sides. So, adding. We realize we're adding. We're doing just what we just did before. So let's start talking about what our LCD is. I'm looking, looks like we're going to have an LCD of 2 times 3, right? Our 2 and our 3. Then times our x minus 3 times our x plus 1. All right, let's play the what is missing game, okay? So if I look at this first one, what is missing? This first fraction, what's missing in the denominator? Well, the denominator is missing the 3, and the denominator is missing the x plus 1. Okay, so I'm multiplying both numerator and denominator times 3 times x plus 1. And that would be a 30. And I'm just going to multiply the first term right now, but that would be a 30 times x plus 1. And it all works out. It will work out the same. Some of you are like, why aren't you multiplying all of them, Miss B? We will. We're going to multiply that 30 inside of there in a sec. But let's just get rid of those two integers just right there in the front, right? So I'm just multiplying those together. Now let's go to the next fraction. What's missing? Let's see what's missing to find this perimeter. Well, we got the 3, but we're missing the 2. So let me get rid of this equal sign. So I'm multiplying this next fraction by a 2. So I got a 2 and then a times, what else is missing? Well, it's missing the x minus 3, right? And so the numerator, I'm doing 2 times my x minus 3. And I'll just do the same. I'm going to multiply. I have my plus sign. I bring it down. And then I'm just going to multiply here, which will give me my 16 times x minus 3. Now, those of you who are like, Miss Bennett, are you going to multiply it all through? I will. Okay, so let me go ahead and start multiplying it through. for the first term, I would get a 30 times x and a 30 times 1, right? So we would have a 30x plus 30, all right? And that's plus, I would have a 16 times x and a 16 minus 3. 16 times x is 16x. And a 16 times a negative 3 is going to be, what do we got? 48. Okay, so I got 8 negative 48. All right. Now, let's look at the denominator. The denominator, I'm going to again combine this, the 2 times 3. I'm going to combine it now. That would be a 6 times x minus 3 and a x minus 1. All right. And let's go ahead and combine like terms. Here we go. And let's change back to our custom pen. Combining like terms. I'm going to combine my the x terms, right? So the 30x plus the 16x, that's going to be 46x. And I look at my 30 minus 48, and that's going to be a negative 18. And I'm going to get rid of this strange mark right there, yeah. All right, and all of this is over 6 times x minus 3, x minus 1. So here, my perimeter, and Miss Bennett is going to, there it is. My perimeter is equal to 46 x minus 18 over 6 times x minus 3 times x minus 1. So, all right, guys, you have taken your guided notes. We have talked about the perimeter, and this is all that I have for you tonight. When we get back in class, we're going to practice. Now, what I want you to do, the only other thing that I want you to do is I want you to go back through your notes, and I want you to just ask yourself, ask questions throughout, or write down the questions throughout each example. So if you had any questions as I was going through the examples, write down what questions you felt were tricky. How did you do this, Miss Bennett? Write those questions down so we can address it when we get to class. All right, guys, see you tomorrow.